This video is about sequence, series, and sigma notation. Sequence is a list of ordered numbers. The members of a sequence are called terms. For example, 3, 7, 11, 15. We see the first term is 3, second term is 7, third term and 11, etc. For a series, domain means relative position of each term. We say that's 1, 2, 3, 4. That will be the domain. Range will be the actual terms of the sequence. We call 1, 2, 3, 4, that is a term number. We call members of a sequence that's term. A sequence can be finite and infinite. When a sequence has a last or the final term, we call this a finite sequence. When a sequence continues without stopping, then we call that a infinite sequence. Like this one is infinite sequence, and sequence 1 is a finite sequence. Both sequences have a general rule, a sub n equals 2n, where n is the term number and a sub n is the nth term. For example, find the first 4 terms of each sequence. For number 2, we will draw a table. We have n, we have a sub n. Since we're looking for the first 4 terms, that's n equals 1, 2, 3, 4. Then a sub 1 equals, plug n equals 1 into this general rule. You got the negative 2 to the first power plus 7 equals 5. A sub 2 equals negative 2 squared plus 7 equals 3. A sub 3 equals negative 2 to the third power plus 7 equals negative 1. A sub 4 equals negative 2 to the fourth power plus 7 equals negative 9. For number 3, we just plug 1, 2, 3, 4 for this n. We got the a sub 1 equals 1 plus 7 over 9 minus 1. You get the 8 over 8 equal to 1. A sub 2, that means second term, equals 2 plus 7 over 9 minus 2 equals 9 over 7. A sub 3 equals 3 plus 7 over 9 minus 3, get the 10 over 6, 5 over 3. A sub 4 equals 4 plus 7 over 9 minus 4, get 11 over 5. It's like a function. Function we use f of n, while for sequence we use a sub n. The position for variable is over here. For function, the variable is over here. Now for number 5, a sub 1, that's the first term. Negative 1, 1 plus 1 times 7 times 1 minus 2. You will get negative 1 to the second power times 5. You will get the 5. A sub 2 equals negative 1. 2 plus 1 times 7 times 2 minus 2. You will get negative 1 to the third power times 12. Negative 12. a sub 3 equals negative 1 to the 3 plus 1's power times 7 times 3 minus 2. You will get negative 1 to the 4th power times 19 equals 19. For a sub 4 equals negative 1 to the 4 plus 1's power times 7 times 4 minus 2. You will get negative 1 to the 5th power times 26. You will get the negative 26. For negative 1 to the n plus 1's power, that means you have odd position. That's a positive. But for even position, that will be negative. In other words, you will get the positive than negative. Positive than negative. For negative 1 to the nth power, you will get the negative, positive, negative, positive, this pattern. For sequence, we have explicit and a recursive sequence. Explicit formulas give the specified term a sub n based on its term number n. So you get the a sub n equals f of n. For recursive formulas, give the specified term a sub n based on its previous term, a sub n minus 1. For recursive formulas, the starting term must be given. For example, this is a recursive sequence because your term is based on the previous term. You have to know the meaning of this formula. A sub n equals negative 3 times the previous term plus 10. Therefore, you have a sub 1 equals 5. A sub 2 equals negative 3 times the previous term, that's 5, then plus 10. You will get negative 5. Then a sub 3 equals negative 3 times the previous term, that will be negative 5, then plus 10. You will get 25. A sub 4 equals negative 3 times the previous term, 25, then plus 10. You will get negative 65. So remember, any term you will get from previous term. Make your previous term times negative 3 plus 10. That's how you get that. For number 8, that means 3 to the previous term's power. We got the a sub 1 equals 0. So a sub 2 equals 3 to the previous term power. Therefore, you get 1. A sub 3 equals, still look at that 3 to previous term, that's 1. So here's 1 equals 3. For a sub 4 equals 3, you do previous term here, you will get 27. A series is the indicated sum of all the terms of a sequence. We have a finite sequence like this. Finite series means I add all the members of a sequence. Series is the sum of the terms of a sequence. Infinite sequence. Infinite series. Define S sub n as a sub 1 add a sub 2 keep going to the a sub n. In other words, a sub n, you always starts with this a sub 1. If we want the sum of part of the sequence, we go to use sigma notation. This is sigma notation. Read as the sum of a sub k as k goes from m to n. A sub k, that's the kth term formula. K is the index number. M is the starting term. N is the ending term. When k equal to 1 to n, we can use S sub n to show this sigma notation. In other words, S sub n, you have to get started from a sub 1 plus a sub 2 to go to a sub n. This is a very important fact. Sum of a sub k as k goes from m to n. Then I can use S sub n minus S sub m minus 1. Find the indicated sum for each sequence. Fourth partial sum of a term, a sub n equals negative 5n plus 3 over n. Basically, I'm looking for S sub 4. Therefore, you need to figure out a sub 1 equals negative 5 times 1 plus 3 over 1. You will get negative 2. A sub 2 equals negative 5 over 2 plus 3 over 2. You will get negative 7 over 2. A sub 3 equals negative 5 times 3 plus 3 over 3. You get the negative 12 over 3 equals negative 4. A sub 4 equals negative 5 over 4 plus 3 over 4. You will get negative 17 over 4. Therefore, for S sub 4 equals a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, you will get negative 2 plus negative 7 over 2 plus negative 4 plus negative 17 over 4 equals, you will get negative 55 over 4. For number 13, formula is a recursive formula. That means your term always negative 1 over 4 multiplied by previous term. So we got the a sub 1 equals 64. A sub 2 equals negative 3 over 4 times 64. Get negative 48. A sub 3 equals negative 3 over 4 times negative 48. You will get positive 36. Then a sub 4 equals negative 3 over 4 times 36. You will get negative 27. Therefore, a sub 4 equals a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. You will get 64 plus negative 48 plus 36 plus negative 27 equals, you will get 25. For number 15, that equals a sub 1 plus a sub 2 plus a sub 3 a sub 4 plus a sub 5 plus a sub 6. Let's make a table. It's easier. I have n, I have a sub n. We plug in 1, you will get 2 times 1 plus 5. That equals 7. For 2, you will get 2 times 2 plus 5, get 9. 3, 2 times 3 plus 5, you will get 11. Keep going, you will get 13, 15, and 17. Then you add all this together. 7 plus 9 plus 11 plus 13 plus 15 plus 17. You will get 72. For number 16, that means a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. Therefore, you will get 2 to the third power plus 2 to the fourth power plus 2 to the fifth power plus 2 to the sixth power equals 120. For number 17, that means a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. So we get the n and a sub n. That is n squared plus 1. 2, 3, 4, 5. 2 squared plus 1 equals 5. 3 squared plus 1 equals 10. 4 squared plus 1 equals 17. 5 squared plus 1 equals 26. Then you add these four numbers together. That equals 58. For number 20, write each series in sigma notation. For the sigma notation, you have to make sure you have general formula of form a sub k. Then k goes from m to n. In other words, you have to get the starting term that's a given. We need to figure out the ending term. For 20, you could say this is a 2 to the third power. Here is a 3 third power, 4 third power. N equals 4 means this is a fourth term, fifth term, sixth term. For 1000, that's 10 to the third power. I don't know what's this term. You have to figure out for ending term number. You need to observe this is a 4, that means n. You got the 2. Give you 5, you got 3. So for this a sub n, you could say that is n minus 2 to the third power. This number will be 12. I write down ending term number is 12. I can write down sigma notation now. The sum of n minus 2 to the third power as n goes from 4 to 12. For number 21, n equals 3. That means n equals 3, 4, 5, 6. Keep going. We have 7, 8, 9. So we got the ending term number is 9. For a sub n equals negative then positive, negative, positive. Could say for all the position that's negative. Therefore, we can use -1 to the nth power to show this positive and negative. Now we need to figure out the relationship between 3 and 8, 4, 16, 5, 32. You could see that 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power, that's 32. Therefore, it will be a sub n equals -1 to the nth power times 2 to the nth power. That will be the general form, -1 to the nth power times 2 to the nth power. Therefore, for sigma notation will be the sum of -1 to the nth power times 2 to the nth power as n goes from 3 to 9. Copy and complete the table. I will go over 31 and 32. For 31, any term equals the previous term plus 2 times the term number minus 1. Therefore, for a sub 2 equals previous term, that's 3 plus 2 times 2 minus 1 equals 6. A sub 3 equals 6 previous term plus 2 times 3 minus 1. 3, this is a 3. So you get 11. For a sub 4 equals 11 plus 2 times 4 minus 1 equals 18. So we get the sequence 3, 6, 11, 18. Check the distance between two terms. You will get 3, 5, 7. One more distance, you will get the 2, which means this is a quadratic function. For the term number, this is 1, 2, 3, 4. Then you will get the a sub n equals n squared plus 2. So for a sub n equals n squared plus 1, you will get the 1 squared plus 1. That equals 2. A sub 2 equals 2 squared plus 1 equals 5. A sub 3 equals 3 squared plus 1 equals 10. A sub 4 equals 4 squared plus 1 equals 17. So we get the 2, 5, 10, 17. We can write down recursive formula that's a sub 1 equals 2 and a sub n equals your previous term a sub n minus 1 plus this is a 2n minus 1 and n greater than equals to 2.